This is just a quick video explaining slant asymptotes from activity 6. I'm going to skip down here to the bottom to problem number 2 and the definition that's right underneath it. Underneath we have this definition here. The line y equals x in the problem above is called a slant asymptote of the function. So it's neither horizontal nor vertical. It doesn't classify as either one of those. It is a slant asymptote. So what this means is the degree in the numerator of the function is 1 degree, exactly 1 degree greater than the degree in the denominator. So if we go back up and we look at that function again, we've got x squared plus 1 over x. The degree in the numerator is 2. The degree in the denominator is 1. So 1 degree greater above, which means we have a slant asymptote. Okay. In this graph here, if you look at it, if you were to graph it on your calculator, hopefully you would notice that on the left and right side, your graph is approaching y equals x. That would be your slant asymptote right there. And so the way to figure out what your slant asymptote is to just divide your function and ignore whatever remainder you would get. So if we look back up here again at this function that we had, we want to do synthetic division. So you should be able to do synthetic division for most of these problems. The way to make your denominator 0 here is to put a 0 in for x. So we're going to use that in our synthetic division. And then we're using our coefficients up here. So we have a 1 for the x squared, 0 for the missing x term, and then a 1 for the constant. Going through and doing synthetic division, we're going to ignore the remainder, the last number we get. So we would end up with y equals x. That is the equation for your slant asymptote. Okay. Going to the next page, problem number 3, I'm just going to run through this problem really quickly so we can understand how this works and how to graph this. Starting out, we're going to write the equation for all asymptotes. Starting with our vertical asymptote, the rule is still the same. So whatever makes our denominator 0, so we're going to have x equals 2 for our vertical asymptote, and we can put that on our graph over here. And then we have to figure out if we have a horizontal or a slant asymptote. So if we look at the function, we have a greater degree in our numerator than in our denominator, so we don't have any horizontal asymptotes. It is 1 degree greater in the numerator than the denominator, so we have a slant asymptote. To figure out what the equation is for our slant asymptote, we're just going to divide this using the synthetic division that we learned in the last unit. So to make the denominator 0, we would use a 2. So that's going to go on the outside. And then we're going to put our coefficients in. So x squared has a 1. Our missing term x has 0 as a placeholder. And then we have a negative 1. Going through and doing our synthetic division, we bring down the 1. 2 times 1 is 2. This becomes a 2. 2 times 2 is 4, and then we add these together and we get 3. That's the remainder. We don't need that, so we can just cross that out. So our equation is y equals x plus 2. So we can go ahead and graph that as our slant asymptote on the graph. So I just make small marks here so I have an idea of where my asymptote is going to lie, and then I can draw in the dashed line. Okay, so you'll notice we still have these two regions where we should have pieces of graph in either of those regions, in both of those regions. To help us figure out where our graph lies, we can identify the x-intercepts and the y-intercepts. For the x-intercepts, it's still the same rules. You're looking at what makes your numerator 0. So that's going to be 1, 0, and negative 1, 0. You can put those points on here. And then for your y-intercepts, you're just going to put 0 in for your x values, and you should get out 0, 1/2. We can put that on here, and then we can connect. We can see we have these 3 points here, so that's where our graph should lie. As we walk off on the left side, we should be approaching that slant asymptote, and we do not cross over the vertical asymptotes. To figure out what happens on the right side of this vertical asymptote, we can go back up and look at the denominator here, the part that represents this asymptote. So the x minus 2, which gave us that asymptote, has an exponent of 1, which is odd, which means that on either side of this asymptote we should be going in opposite directions. So again, approaching that slant asymptote on the right hand side.